Imagine a quarter circle hiding a mystery shape inside. Can you guess the orange shaded area? Only intelligent people can crack this. Problem looks bit confusing because it was inscribed in a quarter circle, but we can do it very simple way. We have given a quarter circle with a radius of 10 units. Inside a orange semicircle is placed in such a way that its arc is tangent to the bottom of the semicircle. First mark the center for the orange shaded semicircle and also radius as r. This is side length is r and the other side length is r and its diameter is 2 times r. Now let's draw the radius to the point of tangency. Whenever a radius is drawn tangent to the point of tangency, it is always perpendicular to the tangent. That means this angle is right-angled. Look at this green shaded area, both of this are right angles by the radius r. And the vertex of the other angle is also right-angled, and this fourth angle is also a right angle, and this is shaded is nothing but a square. Now this length is r units and also this length is r units. Now look at this right angles formed by the radius of the quarter circle and the diameter of this semicircle. Here the base is r units and height is 2r units and hypotenuse is 10 units. Now our favorite Pythagoras theorem, r square plus 2r square is equal to 10 square. Then we get us r square plus 4r square is equal to 100. Then 5r square is equal to 100. Then r square is equal to 20. Finally, finding the orange shaded area of the semicircle. Area of semicircle is equal to 1 by 2 pi r square. So substitute the value of r square. Then we get us 1 by 2 into pi into 20. Then area of the semicircle is 10 pi. If you enjoyed solving this problem with me, please don't forget to like and subscribe.